Hi, everybody.
Hello.
Good morning, good afternoon, or good evening, depending on the time zone. So yeah, we have today like a pretty short webinar about the most interesting features that we have added into Visual Nand Reconstructor update, which is 4.0. It's a 4.0 because we we added one quite a powerful feature to the update, which is a GPU ACC correction, and yeah, so it's just the beginning of our moving onto GPUs. Let me share a screen with you guys. I'll start from really little features, and then we move to the end to the most important ones. But there's a really like a very small for those of you who already been our user for years or for months. Yeah, these little features will definitely improve your life, improve your work with Visual Nand Reconstructor. Yeah, one of you dropped a message in the chat. Yes, we have added these features of double or reduce block size 2 times. So yeah, you can just click here now in order to. I hope you can see my screen. Yeah. Sorry, can you see my screen?
Yes, we see.
All right. Yeah, so yeah, you can basically double block size or reduce block size twice. Several people asked about the feature. We have added it, and yeah, it's pretty convenient now. You don't have to go back and change it and calculate it in calculator and so on. There's one quite important feature which we added to mark stable. We will show now not only physical address of the block, but also the physical block number. So it can really help you in a lot of cases to figure out why you have duplicated blocks. Like if it's like different banks as on this picture, or whether it's a wrong just a wrong block size. So you can see 2 physical blocks go together, and yeah, so this is really tiny, tiny feature, tiny improvements that can help you in your daily work. Also, we added the mark stable autosave feature. Sometimes, if you have like a very large mark stable, and sometimes you just close the case without saving it, or you forgot to save it. It's pretty annoying sometimes. You can lose basically all your work which you did like within 20 minutes or half hour. And so now mark stable is automatically saved every 5 minutes, as I remember. But you can also disable it in the settings. So yeah, these are really tiny improvements that we added just to simplify daily life, daily routine, basically. Yeah, and the next feature I'm going to show you is a pretty important, and it's we improved significantly ReadRetry algorithms for pretty much all of memory chips, SanDisk, Unix, Samsung. Let me show it. So I've got a case here. I hope you can see the Visual Nand Reconstructor. All right. And yeah, so that's a pretty typical case where you have reader, physical image, XOR element, and the offset and ECC element. So this particular change we did to ReadRetry allows you to, well, first of all, find proper parameters much faster than it was before, and also they're more optimal, and they will correct your data like much less efforts or attempts than it was before. So here I've got a typical Unix memory chip. This is one of problematic Unix memory chips, by the way, and I've got here, I pulled out like about 10 blocks, as I remember. You can see it's about 18 megabytes, just to quickly show you, how the feature works. And if you look at the ECC map, it's pretty bad. It's a typical situation for many Unix memory chips, the recent memory chips from Unix or Hynix, whatever we call them. And yeah, so usually in such situations, you definitely want to correct dump at first, especially because we have GPU correction now. And then you would want to reread dump, because reread pages, reread those read pages, because they are so, this dump is just heavily damaged, I mean, the dump from memory chip. This particular memory chip was worn due to very high load of, write and erase cycles. There were too many of them, and chip got almost destroyed. And so the ECC map looks really bad, really bad here. And so you go to for reread dump. So keep in mind, this dump was already corrected using our new feature, which is a correction on graphic cards, GPU correction. So it's always corrected, but it wasn't reread yet. And so, well, as you can see, this particular window, for those of you who already know how this works, the window didn't change that much, but we have added a couple of features here. You can now set address that you want to basically set address from which you want to test ReadRetry. And secondly, you can set how many pages you want to test for ReadRetry. So yeah, let me just show you, and I will explain meanwhile what the changes do. So here I'm going to show you how it worked before. So first of all, let's go for this number of pages feature, number of pages to test. So it used to be one. Like we used to just pick up, random page from the block, find proper ReadRetry values for this page, and then we would apply it on the whole dump, on the whole attempt, or on the whole one pass of reread. It was working all right on most of the chips, Samsung, SanDisk, it works okay. But on the recent Unix chips, it just doesn't work at all. Those of you who dealt with Tesla memory chips from Tesla cars and some other cases, you probably know what I'm talking about. So that's how it was, one page, and I'm gonna set here just one pass just to speed it up, since reread takes a while. Yeah, so now ReadRetry algorithm is trying to find, the best parameters based on one page analysis. As you can imagine, different blocks in flash memory, especially in these Unix chips, they get worn very differently. Like if one block was erased like 10 times and another block was erased, well, say 1,000 times, they have so huge difference in ReadRetry parameters. So in order to read those blocks, you actually need to apply very different ReadRetry settings. And so here I'm basically running the ReadRetry. So now we're trying to, based on one page value, we're trying to correct all those blocks. And of course, it doesn't work really efficiently as well, as you can see. So you can see from the first pass, we corrected just 5 pages out of around 900 damaged pages, read pages. Obviously, that's pretty bad result. I mean, if you check your map, it barely changed. It's like 5 pages got fixed. It's just simply because the value that was taken from a particular block, it just doesn't match to other blocks. And the value itself was very, it was not the best one, let's say. So now what we changed here that improved the quality of rereads quite dramatically is you can actually pick up as many pages as you want. But normally we would go for 8. That's quite an optimal amount of pages to test. So when I pick 8 pages, it'll basically take 8 pages. It'll find all ReadRetry parameters for all these 8 pages, and then it would average them. So it'll basically like find best ReadRetry value based on average of 8 pages. And of course, if you set, I'm going to set just one pass now, but if you set like much more passes, yeah, it'll correct most of the errors in the dump. You might still have some, errors here and there, but majority of pages will be fixed. So yeah, so here I'm gonna go another pass, but now we set in ReadRetry value based on 8 pages. And keep in mind it was only 5 pages fixed. Now I'm gonna run it again. Second pass. The test of values itself would take a bit longer, because now there's a lot of things going on now. And when it tests ReadRetry value, there's a lot of things, well, we're going on even when it tests 1 page, but now it's just 8 times more things to test. And so this particular step, may take a while, maybe 30 seconds, 40 seconds. So this is quite important change, and I would certainly recommend you for all devices you have. If you have quite a bad quality dump, you have to try to set more pages to test. So that might improve a lot of bit errors, a lot of bad pages. So it's almost finished. So it says ReadRetry is found and applied. Now you can see the amount of pages, amount of corrected pages quite dramatically improved. Of course, it's still not ideal. Obviously, we just did one quick pass, and there's still plenty of errors. And this is where a second feature comes very handy. When you don't set address to test, it will just pick up randomly some of the pages for analysis. But what you can do now is actually, well, we can close it for a while. You can just crawl your map, and you can say, all right, I want to improve this block, this particular block. So you see the white line here is a border of blocks, right? So we can say, all right, let's take this value and let's find ReadRetry for this particular block, and then let's just try to fix the whole dump based on this value. So you can just right-click on the place you want, copy address, and then go back to reread. I'm just going to set it again 1 pass just to make things faster, because obviously you don't want to just sit and wait here for 3 or 6 passes to go. Normally you would set 3 passes at least, but I would probably recommend to go for even 5 and 6, depending on how many bit errors still remain. So now I just pasted this value, which I copied previously. And now keep it 8. We keep it 8 as it was. So the amount of pages to test will reduce a count of reread passes sometimes 2-3 times. So it makes sense to, and we set by default now it's 8. So you don't even have to change that. So let's start and see if it fixes. If it helps to fix more of the pages. Yeah, it's still, again, it takes a while to find the best value based on average of 8 pages. This particular chip may take several more cycles, but the main idea here is just to show how to use these new features. That the features look really small, and just a couple of new settings to set. That makes in many cases a huge difference. So don't forget to pay attention to those little changes. Oh, you can see now it's huge. I mean, the improvement is just dramatic here. You see, we almost got everything fixed just within 1 more pass. You see now we got 137 pages still uncorrected, but about 600 pages got fixed just by selecting precisely the place to test, basically. And this feature, sometimes you did 3 passes, but you see it's still not really enough. But at the beginning, I would recommend you just not to bother about it. Just go for standard settings, make 3 passes of your read, and then just go for the map and evaluate quality, the overall quality of the dump. Scroll down a little bit here, there, and just see how your blocks look like. And as you can, and what I usually do on the second attempt, let's say when I'm trying to like fix all errors in dump, I would just find the worst possible block, the block that has most of red pages, and I would pick up this value, put it in here, and then run maybe 3 more passes. And with a very high chance you will get it fixed. So that's quite well, small looking, but quite a dramatic change of the ReadRetry algorithms that we have quite dramatically improved in this update. There's still room for improvement, obviously, and we are working now specifically on some of the problematic Unix chips. So in the upcoming update, we'll improve it a bit more. But yeah, now it's possible to fix most of the errors, maybe not 100%, but in most of the cases, 99.9% of that. So that's pretty much all about, particularly about ReadRetry feature that we have dramatically improved. And now let's move on to the probably most interesting part of the webinar, of course, which is GPU ECC correction. Of course, I'm not gonna. Most of you probably seen the news, and there was a nice table of results, a nice graph, nice diagram, which shows you how faster now is ECC correction. And yeah, I would say, like, for me, it's been like for years it's been a problem. Like I would say, of course, there are many problems in this area. Sometimes you have unknown XOR key, sometimes you have this, that, but the biggest problem was, for now, in my opinion, which affects daily routine of data recovery engineers, is ECC. Obviously, devices getting bigger, and nowadays they're just huge. 120 gigabytes, 256 gigabytes is just a normal average device nowadays. And the correction of those would take, you can imagine, comparing to 16 gigabyte device, 128 gigabytes, well, it will simply take 16 times longer to fix bit errors. And the codes, BCH codes themselves, they got larger as well. The larger code it is, the much more processing time it requires to correct all the errors. And obviously, we thought a lot about it. We tried, we have very different CPUs here in company, mostly Core i7s from 6 series to 9 series. And yeah, CPU is getting better, but obviously, there's no dramatic improvement in speed, simply because you have limited amount of cores. And you're probably never going to get a CPU with 1,000 cores. But you can easily get a graphic card with thousands of cores nowadays. And average decent level graphic card now has about 2,000 stream processors. And yeah, so we decided, all right, so let's just almost completely stop any researches of ECC based on CPU, because it's just never going to get faster. And we decided to completely move onto graphic cards. And yeah, let me show you just a quick video of comparison of the same case corrected on the quite a powerful CPU, and then the same case corrected on quite powerful graphic card. So hold on for a sec. Right, let me just share it. All right, so we decided to prepare a video since we just wanted to put 2 videos together so you can see yourself, you can compare. But obviously, the best the best evaluation is evaluation by yourself. So you just better grab some graphic card and test it out on one of the dumps. But anyways, let me just run the video. I hope you can see the video. So here we got on the left side, you see the dump, which is being corrected using quite powerful processor, Core i7 9 series. On the right side, we've got a Radeon RX 5700 graphic card, which is quite a powerful one. Well, the most powerful in the world, of course. So yeah, you can see the maps on the both cases. The maps are pretty bad. I mean, they're not too bad, but as you can see, light green means there's just many errors. Of course, all these light greens are correctable, right? And yeah, so the amount of red pages here is not too large. So yeah, obviously it will still require a couple of reread attempts, but yeah, it's correctable even within one pass. Pretty good quality. So yeah, let me hold on video for a sec. Yeah, you've got now two buttons. If you noticed, you can also check it on the news. We got a screenshot there. So you've got correct dump feature. This is old school CPU correction. And we have a correct dump on the GPU. So that's just another function separated from the CPU correction. And this is what I certainly recommend everyone to use in every single case nowadays. Don't even try to do correction on the CPU. Even built-in graphic cards, they can increase your speed of correction like at least 50%, 30 to 50% sometimes. And here you can set the buffer size on the right screen. You can see you can set the buffer size for basically buffer size for correction. Honestly, like you can try to do some experiments, but we haven't found really any like some kind of like a I don't know some dependency on what works better, which size better. The only thing we found is the larger buffer is, the larger your VRAM is, the better it does, the better it works. So here by default we use the maximal amount of memory which is available on a graphic card. So yeah, so we run a timer here. You can see on the left side and on the right side. You can see basically this is a time-lapse video with the different speeds. So on the left side, on the processor, you can see we synchronize percentage of correction, which is pretty much similar, 25%. But time-lapse is on the left. Is time goes much faster on the left. On the right, yeah, the time is slower. So you can see how much different it is. It's about, well, from what I can see, about 5 times improvement now on this particular code. So which is pretty good. If it takes like 1 hour on CPU, you can make it like within 12 minutes on the GPU. And this is not most powerful GPU. Obviously, amount of errors correct is going to be same. I mean, nothing. This is not reread, right? This is just a correction without without using memory chip itself. So this is just dump correction. Result is just same, but yeah, time spent is quite different. As you can see, we got about around 50 minutes here, and then around 10 minutes here on the graphic card. Yeah, so that's pretty much there's nothing new here from the point of view of like it's not a new ECC code or anything. It's just a huge improvement of speed of correction. We have a big plans actually in the next updates. What we're doing now related to graphic cards, we move in reread, dump reread also onto graphic cards. Because sometimes, like the case I showed you just a couple of minutes before, like a half dump was read. So in case when you have half dump read, you're gonna need to reread half of the dump. And you can imagine the time for correction is gonna be also quite long. So reread now works on the classic CPU, so that's what we didn't update yet. But ECC correction itself now working on the graphic cards. I have seen, I think, question in chat. Let me check that. 1 sec. Will reread also reread empty blocks? Well, not really. When you do correction, when you do ECC correction, basically it will fill in the ECC map file. So once corrected, the block is not going to be touched anymore. And if this block has red pages, then only those red pages will be reread and corrected. We got a couple of questions from users, a couple of suggestions, a couple of questions, especially from forensic guys, because as we know, those guys who work in forensics, they have quite powerful GPU stations, like large computers with a bunch of graphic cards for password cracking. And we have a really interesting idea for the next update to add multi-GPU support. It's actually, we already have it in alpha version. And I have to say, we tested it now on like 6 graphic cards put together, and speed improves almost linearly. So you can tell you got 2 cards, yeah, you'll be able to correct 1.7 times faster, approximately. But this is for the next update we have. Also, we also got a question like which graphic card I have to buy. First of all, we put test results onto the website in the news. Let me show you for those who haven't seen that. The answer, like which card to buy, is pretty simple. The more powerful your graphic card is, the better, the faster you can get ECC corrected. Yeah, let me just share your screen. So here you can see the results from 5 different dumps and several different graphic cards. Just a quick remark for those of you who's not planning, who don't have so many cases, let's say, who's not planning to buy graphic cards specifically for for ECC correction, you can still use your integrated card in Core i7 processor, for instance, or Core i5 processor as well. They have very similar cards, and it will give you quite a decent improvement of the speed, even without any additional investments. So honestly, we haven't tested yet on RTX 6000 series, 3000 series from the NVIDIA, because there's a shortage of cards now, and they have some bugs. So we planning to get one of those, perform some in-depth tests on the same dumps, and I think we will put it into internet so you can see how this RTX, this newest series, how it does perform. Yeah, so yeah, that's basically our plans specifically for ECC multi GPU correction. It would be nice to have 30 time or 40 time increase if you use multiple cards. And also another feature is reread, page or block reread based on the GPU. This is what we're doing now with in GPU direction. We're also thinking about other features since you can do it so much faster on GPU. So we have big plans. We have a lot of plans to move a lot of things onto graphic cards. So if you're planning to buy one, it's for data recovery purposes, it's a probably good time, because we're gonna move a lot of stuff to graphic cards. So well, I guess I'm finished with this quick. It was just a quick wrap up of the new features that we added to the 4.0 update. Of course, we added also a lot of resources, some new pinouts here and so on. You can read it all on the website. There's also detailed information about times, which it takes for correction. If you guys have any questions, you can also drop them to Help Center about which card to get, which card is better, which graphic card is better. Yeah, that's all I wanted to say. Thank you.